Thank y'all so much for coming out to hear me talk about what we've been doing at SideFX Labs. My name is Danicka Oglesby, and I'm a technical artist on the team. And whether you've never heard of Labs before, or if you've used it a little bit or used it a long time, hopefully there's something in here for everyone. So I'll get started, and if you've never heard of SideFX Labs before, I'll just give an overview of who we are and what we do. So SideFX Labs offers a suite of 270 high-ish level tools, and I say high-ish because sometimes they can be pretty low level, or sometimes they can be higher, more artist-friendly tools, such as like we've got a tree generator and building generators that will create these almost finalized art assets, or some pretty low-level tools like we have a library of Vex functions now, which I'll touch on a little bit later. But the goal of Labs is to simplify common workflows used by individual users or used by studios, things that you find yourself doing over and over again, or things we see studios are doing over and over again individually, and we say, hey, maybe we can think of something that can help everyone out. And what Labs is we're really an auxiliary tech art team for everyone who uses Houdini. So it's not studio specific, user specific, it's for everyone. And so we generate our tools for hopefully everyone's workflow that they can benefit from. And also a benefit of a tech art team dedicated specifically to Houdini is we hopefully lower the learning curve quite a bit, because Houdini can be kind of daunting for new users. They have to learn how to chain up node networks by themselves, operations themselves, and Houdini nodes can be pretty low level and complex and maybe not super artist friendly. And so when we wrap up our tools, we give people almost like a landing spot to start on first before diving to the deeper stuff. And all of our tools are completely accessible. So you can open up a tool, dive in, you can see the entire node network and see what was sort of going on in our minds when we were making the tool and learn from Houdini that way. Like that's how I learned, is I opened up other people's HIVE files and I said, what were they doing here? So all of our nodes are completely discoverable if you want to dive in. We also do some in education. We're kind of a jack of all trades as far as our pipeline goes, but as far as what we offer. So, we don't just offer tools, but we try and teach people how to use these tools that we've made, or why we made the tool the way what we did, or we give them demos on how to artistically use these tools. It's all about helping our users, helping people use Houdini more effectively, again, either as an individual or studio-wide. And we do consulting and support. We're very in touch with people who use Labs. We always are looking for feedback, always are trying to stay on top of industry trends and see where, real time is going. And so we can build solutions or work with people for solutions in those areas. And this is a demo of me just scrolling through our documentation of all of our tools that we have, because it can be extensive. And we have come up with a few ways to sort of help discover in this extensive suite of tools, and I'll touch on a lot of that later. Again, we're like a jack of all trades. We try and help in every little aspect. We don't just stick to environments or terrain or UV unwrapping. Like, we try and help everywhere. What I describe it as is when we talk to our users, we develop a sort of heat map, like hot spots of areas. Like, I'm having trouble here, or we're doing research and development here. And so wherever those hot spots are, we also try and pull our efforts into. And then some faces behind the team of SideFX. There's myself, our lead, Alan, and Christos, who's here with us. I'm picking on him a little bit to just give some faces behind, because Labs has gone through some evolutions. We've had some like rock star predecessors. And so just to show you who we all are today. So let's talk about what we've done new since last GDC, what we've done in 2022/beginning of 23. And I'm going to demo first our new tool, Fast Remesh. And this tool is remarkable for a number of reasons. So if I ramble too much, it's just because, one, I personally worked on it, and two, is I really am excited about this tool. So Houdini's native remeshing can be kind of cumbersome on high poly meshes. It can bog down in memory or crash, and it's great at what it does in certain circumstances, but this tool was contributed by a community member. They submitted this to a tech art challenge, and the concept was just so clever for a number of reasons. So first, it takes advantage of a couple of Houdini features. One, remeshing is a lot faster if you do it on smaller meshes. Two, if you cut up a mesh, as denoted here by the different color areas, if you cut it up, and remeshing is faster. But if you take advantage of Houdini's compile blocks and multi-threading, it can go even faster. So I think I was testing with maybe a 3 million poly mesh, it was remeshing in about a minute or less, depending on the settings, where maybe it might take half an hour or it might crash my computer or something. And so the really clever things about it is it combines the fact that you're using smaller meshes with compile blocks to really zip those remeshing times down. And in the realm of real time, performance is always on everyone's mind. It's like, how can we get this to run faster and better? How can we get the same results for cheaper? And that mentality carries over into what we do in labs. It's like, how can we get our users better tools, more friendly tools, faster tools? And so that's why this tool in particular is like sort of like an icon for some theories and things I have about labs. And getting into more the nitty gritty, you can tweak your sectioning from a few different perspectives, and you can tweak the remeshing settings. And there's some videos out on this, on how I made the tool and what it does and why it is the way it is. And so born out of Fast Remesh, so Fast Remesh sections out your geometry, then it performs the remeshing operations on those section pieces. Well, I got a suggestion from Paul, a former member of SideFX. He's like, hey, I just want the sectioning part. I don't want the remeshing part. So can you take the sectioning part out and make that its own tool? And I was like, oh yeah, absolutely. I just took the node network out of Fast Remesh, cleaned it up a little to work in a sort of a different workflow, and released it as its own tool. And here you can see several different sectioning processes, like you can section by UV seams, by clusters of primitives, by connectivity, and also by a custom attribute. And all these sectioning processes are like nested. So you do your UVs and you section your UVs out by clusters and you section that out further and further. And so to really give you all that control based on how exactly you want to section this out. And sort of as a result of this, since we pulled this out of Fast Remesh and made it its own tool, we took that entire network of nodes out of Fast Remesh, took that out, subbed this tool into Fast Remesh, and it just works perfectly. So they work seamlessly together. And we changed both UIs to mirror each other since they're sister tools. And so that way, if you're used to using Fast Remesh or you're used to using connectivity and segmentation, you open this other tool and you're seeing a very familiar workflow and process. So it's just, we keep all of these things in mind for usability, for efficiency, and for consistency. Another tool we've released this year is Volume Look Adjust, which is a post-processing node on your volumes. Can convert your volumes to grayscale. You can visualize things such as normals, motion vectors, adjust your density, color, rendering quality, all after it's been simulated, so you don't have to run your simulation again. We have Simple Shapes, which is a sort of cousin node to another node we have, which is Super Formula Shapes. And while Super Formula is based on a mathematical formula, and the shapes are driven by parameter settings, Simple Shapes is much more straightforward. It's a much more artist-focused way of using the tool. Super Formula, I'd say, is like a mathematician's way of using this tool. But Christos, the one who made Simple Shapes, he's like, I want an artist tool. I like tools that work like this, and they do that. And he's like, I'm going to make this tool. So this, I think, is more artist approachable, artist friendly. You can do automatic UV unwrapping and even cut a hole in the center. It's showed in some of the demos. Another tool we have is resample by density or curve resample by density. So you can have even more fine-tuned control over the way you resample a curve. So instead of resampling by target edge length or by a flat density, you can have a variable density that you change your curve by. And you can either drive it by a density ramp as shown here, or you can have it driven by a custom weight attribute you pipe in, or curvature setting is on this. UV unwrap cylinder automatically unwraps UVs on cylinders, on cylindrical objects. I don't know if anyone has unwrapped pipe UVs by hand. I have, and it's terrible. So when, again, Christos made this tool, I was like, I would have loved to have this 3 years ago. This would have been amazing. And so it automatically unwraps these cylindrical objects for you, or if you have more complicated geometry seams you want to keep intact, like these end caps, you can select those seams and cut along those seams, preserve those seams. And this is also really useful to use if you have a trim texture workflow. I've used this node in conjunction with Labs trim textures, and it helped a lot because previously I was doing an automatic unwrap, and I was getting a lot of warping artifacts when the cylinder would connect on the other side. And again, I don't want to unwrap cylinders by hand, and this got me to my end goal one step faster. We have a Kelvin Wakes deformer. And I say deformer because this is not a simulation. This is a wake deformer on top of a grid that has been put through an ocean simulation. So just standard ocean simulation, and then on top of it, I guess it won't play again, but you can see the V of the wake. On top of it, I put the deformer. It calculates the math based on distance. It's actually following a curve I have here. And it creates those wakes in a much cheaper way than running it through a simulation. Another set of tools we have that aren't tools, but they're not, are what we call aliases. And aliases is sort of like a disguise or like a second name to nodes that you're familiar with using, but it wraps up common parameter, almost like a preset, and it does it by default based on the name. So I'll give you an example of what I mean. So this middle alias here, transform from centroid. One common thing people do a lot, I do a lot, is when I drop down a transform node, I want to basically scale from the centroid. So a common tactic is to go into the pivot, translate parameter, and type out your centroid functions for your X, Y, and Z positions. And you do that all the time. And every time I want to do that, I type it over and over and over again. So instead of doing that method, you open up the tab menu as normal, and you can select transform from centroid, and it drops down this transform node with the pivot translate populated already with these functions. So if you have to type these functions 20 different times or 100 different times over the course of your career, like those little tedious things can add up, and we want to eliminate those really tedious things. So like transform from centroid, remove overlap is an alias for our polydoctor node with all the settings configured to remove overlapping primitives. And remove unconnected points is an alias for our add node, because a common workflow for our add node is you drop down your add node, you navigate to the polygon menu, and you click remove unused points to remove points that aren't connected to anything. So instead of clicking through all that every time you want to do it, you go into your tab menu, you type remove unconnected points, and there's the add SOP with everything configured already for you. Another thing an alias is a name for a common chain of nodes. So if you're familiar with using for each blocks, if you type in like for each primitive, it'll drop down a for each begin, a for each end, and they're already wired for you. That in itself is an alias like these are. So we've developed a couple of aliases that do similar functions. So earlier when I was talking about connectivity and segmentation, and like Paul said, like, hey, I'd love to use the segmentation and my own operation in a multi-threaded compile block. So not only did we make that node based on the suggestion, we also made this alias so you could drop down a custom compile block and for each loop, so you can go ahead and get started as soon as possible using multi-threaded compile blocks based on segmenting with connectivity and segmentation. That's a lot of words. But essentially, it just drops it all down for you. So instead of having to wire this all up manually yourself and configuring all the different checkboxes and custom primitive attribute names, it just drops it down for you. And so you can go ahead and throw your operations right there in the middle and get started multi-threading right away based on this segmented geometry. And like that, we have the tree pivot painter alias, which is an alias for Labs tree hierarchy chained to Unreal Pivot Painter. And what tree hierarchy does is it takes our Labs tree generator tools and it extracts the mesh, it extracts the pivot points for use in Unreal with Unreal's Pivot Painter. So that's what Labs tree hierarchy does. Unreal Pivot Painter exports the mesh and the pivot points. And so instead of having to chain hierarchy and then Unreal Pivot Painter after if you make a procedural tree, you can just type in tree pivot painter and it'll automatically connect it and configure it for you. And another thing we've done to our aliases, even on these examples themselves, is when the node is dropped down, it is given the name of the alias. So if you go back into your HIVE file and you say, oh, where did I get this network from? It's been 6 months since I've looked at this file. I have no idea what I was doing here. There's a little hint. So it says compilable segments on the top node. And that's the name we've given, so you can go back and remind yourself what was going on there. We are also introducing custom VEX functions or custom libraries to wrap up functions we find ourselves using over and over, we find other people using over and over. One function or one library is for manipulating different data types. So, I to A is is integer to string, and A to I is string to integer, but there's nothing for floats. So, for example, we have a function that converts floats to string. Or you can loop through your array and make sure all of your entries are unique. So just manipulating data types, and we have a library for math because we're riddled with linear algebra. And you might be a pro with using cross product, but it doesn't mean you want to program it up every single time you use it. And so there's very helpful functions there to help calculate your stuff and get you to your end goal one step faster. And it's currently in Labs. If you look under the SideFX Labs directory under vex/include, all the functions are there and they're documented, and you can go and read what they're doing and what all we offer. There was sort of a suite of nodes that came out of a photogrammetry cleanup process. And some of them were talked about at GDC last year, and then some of them were released this year. And so with photogrammetry cleanup, every scan has its own issues, has its own artifacts, has its own cleanup process. And so we think, how do we make tools that can be generic enough to address a variety of photogrammetry issues that come in? And how can we retain details in specific areas while blurring artifacts or unwanted details in other areas? And so that was the idea behind a lot of these tools that were created. And one of the tools that we created this past year was physical ambient occlusion. The previous version of physical ambient occlusion was not, or ambient occlusion was not physically accurate, and results were based on a random seed. So depending on what seed you use, you could get different results every time, which isn't desirable because ambient occlusion should be a property of geometry. So you should be able to derive it from geometry. I don't know if you can kind of see this left example, which is the previous method. It looks a little noisy in some spots. And if you put in different seeds, that noise will move and flicker, and it just wasn't really desirable, especially for use in an automatic workflow. So physical ambient occlusion was released to be consistent and be a lot cleaner. So these right two examples are physical ambient occlusion. And the middle example is using an exponent value of 0.5, which is technically physically accurate. But that exponent can be adjusted if you need different results, as in the right example that has an exponent of 2. And again, like, it doesn't have to be physically accurate if it gets you the goal or the results you're wanting to get. We have fast Gaussian curvature. And while I don't have like some flashy geometry to show, I have data, which I think is flashy. So again, if you're running over huge sets of polygons, or you're iterating or running over huge data sets, little seconds can add up in the long run. So for here, I have an example of the same geometry being run over a traditional Gaussian, or I don't say traditional, like Houdini's native Gaussian curvature measurement with a measure stop. And the left side is our fast Gaussian curvature node. And same geometry, but if we look at the profiler and what it tells us, it says that the traditional measure stop is calculating in 7.1 seconds, but the fast Gaussian curvature is calculating in 2.7 seconds. And so it's only 5 seconds on a huge piece of geometry, but just imagine that over multiple iterations, multiple pieces of geometry, and that really adds up. We have connect polygon neighbors, which so here we have a piece of geometry, lots of primitives that are connected, lots of neighbors. And what this stop does is it finds the centroid of each one of those faces, and it finds the neighbors of each one of those faces. And it connects the neighboring centroids to each other, as denoted by these like blue lines. So it's only connecting the neighbors. And this was made because tools like cluster or spectral feature extract only work on points. And this way, you have a way to operate on primitives as well by identifying those neighboring primitives, but having those centroid data points. We have clean seams, which works with our sort of in tangent with our UV auto seam node. UV auto seam, or anything done automatically, can produce some unwanted artifacts. So here we see some rogue UV seams in the middle of giant blocks of geometry. So UV clean seams identifies these rogue seams and just cleans them up and fuses the UV seams together. Also along the lines of UV, auto UV nodes, we have merge small islands, which here's an example of our rubber toy geometry. And auto unwrapping it produced a lot of small islands. And what merge small islands does is it takes an island, it finds the closest and largest UV island and merges those together, and then it does that iteratively over and over and over again until you're left with much larger chunks to work with. We have calculate thickness, which is very similar to ambient occlusion, but instead of casting rays outward to calculate, it casts rays inwards, and it can be used for like some cheap subsurface scattering effects. Attribute normalized float automatically calculates or automatically normalizes a range of values from your min to max to 0 to 1. Whereas the attribute remap SOP, you would have to calculate manually. This just does the calculations for you, and then you can adjust your min and max values to fit in a different range. So that's a little bit about what we've done this past year. I would like to talk about a little bit more about who we are and our motivations, and a little bit of what we're planning for in the future. So as I've kind of talked about a few times during this presentation, is how we are really looking at our tools from a user perspective and making sure they're robust, flexible, efficient, and so that all of our users can use them. And I have an example here, is a conversation between Christos and I, because we test each other's tools out and we put them through this sort of like refinement process back and forth. And this is a conversation. I was like, hey, test out this tool, please give me feedback. And Christos is telling me, different visual feedbacks, like feedback based on even how a parameter is named. Is it descriptive? Is it straightforward? Does it get the message across? Is the flow of the UI logical? Does it make sense? And another tactic I like to use is with our interns, is I'll give them a tool with no documentation. And I'm like, what frustrates you? Like, use this, tell me what you think of it, what frustrates you, and we modify the tool based on that feedback. And also, since we're a team of 4 now, we are trying to standardize what we do. So every tool has the same quality. Whatever we release, you can expect the same sort of layout from every single tool. And so we're working on standardizing what we do. And here's another story about another coding optimization story. Because I'm always using the profiler to make sure what I'm doing is as efficient as I can get it. So we are given this chunk of code, and we were asked, how can this be optimized? Can it be reduced in the number of lines? Can it be, can we just remove some unnecessary functions? And what this code does is it returns a value of -1 to 1, and it oscillates on a frequency like a sine wave, but it's only like -1 to 1. So here the z value of the point is -1 to 1, but it kind of looks like a sine wave. So how do we make this more efficient? So Maya and I came up with 2 different approaches. I took advantage of the fact that -1 to the power of an even number is +1, -1 to the power of an odd number is -1. So that in itself oscillates, and I feed in the frequency value into the power to make it oscillate. Maya used a conditional statement. Based on the value, it's -1. If not, it's +1. It also oscillates based on a frequency. So they both do the same thing. They were both reduced to 1 line of code, but there's only one way to show whose code is better. It's running it through the profiler. It's testing it. So we ran it over 1 million points, and the profiler can tell us the truth. My code ran in 0.25 seconds, but Maya's code ran in 0.085 seconds. So, of course, Maya wins because his code calculated in 33% of the time it took my code to calculate. And so even though it's just like a fraction of a second, it really adds up over time, and it's kind of fun for us, really, to sit there and optimize it as much as we can. And it just highlights how important that is to us as a team. Another thing we've done to make tools easier to use is we have reorganized our menus. So we've organized them by categories to hopefully make it easier to discover new tools. So if you go into rendering, you can see what rendering options we have. And it's just more intuitive way to discover the 270 plus tools that we have to offer. So let's take a little look into what we have coming up. Project Dryad and Vitruvius, I'll touch on a little bit in a second. Improved UV tools, more photogrammetry tools. We've looked at what's released already. And I know Maya's working on flipbook textures. He gave a talk on that yesterday. And he's also looking into improvements for VAT, or vertex animation textures. So when I talk about Project Dryad, it's named Dryad because it's dealing with environments and biomes and terrain generation. And the goal of Dryad is to be able to create these large-scale worlds that are driven on real-world models. So like, how does the aridity index affect vegetation growth? How does soil quality affect vegetation like density? How does altitude affect like cliff development? So we really want to approach this from a real-world mindset or model, because we want believable results that are more than just scattering and adjusting density manually or painting in manually, even though there will be lots of room for artist control at every milestone in the process. So it's a steady balance between powerful procedural generation with a lot of intervention in between. Oh, touched on this already. Environment metadata, kind of like what I mentioned earlier, it's like aridity index or soil quality or elevation or erosion, and all of that will be exported as textures as well. You can use those values to drive something on down the line. And then, so I know a lot of my examples, they're real world photos because it's our vision, what we're going for. And you see a lot of vegetation. The vegetation will come in through the artist team. So SideFX Labs, we're very talented, but we lean more technical. So all the beautiful artwork will be provided by the users. We hope to have some presets on our tree generator tools that can be plugged directly in and give you a starting point, and maybe that's good enough, but we want to allow for lots of artist input and fine-tuning to make the world stylized and realistic. Oh, and that just to emphasize the point I just made. And kind of in a sister project to Dryad we have working alongside is what we call Project Vitruvius, which by this image of New York, we are dealing more with like cities and connecting cities and connecting them through like roads and intersections. And we, Christos, it's his baby that he's working on. We are working together on both of our projects to make sure that they can talk to one another. So Christos' cities can work with my terrains and environment. So they're not just working in voids together, they're commingling. Again, he has the same visions for his project, lots of art direction, driven by real world data, road modules, different bridges and tunnels and terraforming of the environment that maybe Dryad makes or someone else makes can be piped into this project. Realistic building layouts, how does traffic work with those road connections, how does procedural building generation work when in different city blocks, different city layouts. But what I think is really cool, or it's all really cool, but one really cool feature that we're looking at, I find very interesting, is the procedural layout of the interior of buildings. So exterior layouts have been done. How do we do interiors? How do we make those buildings searchable or discoverable? We want to go in, and we've had lots of discussions. We've met with an architect and we've talked to him about how homes are made. And even though it varies culturally, a really great point that they pointed out was, when you walk into a home, you have all your communal areas first. And the further you get into your home, the more that's where the private rooms are. And it's then we get to brainstorm. It's oh, what does that look like? How is that arranged? How does that vary between cultures, between home types? And so it's a really interesting area to brainstorm in. And then, after we have those interiors built out, how about some procedural set dressing as well while we're at it? So those are two projects that we're leaning hard into this year. We're devoting, Christos and I are devoting a lot of our development time into these projects. And hopefully in the next year or two, they'll be fully fledged. Oh, also another note on that is we want to release our these projects in pieces. So we don't want to wait until the entire project is done and release it all at once. It's a set of nodes, it's a suite of tools, and as each tool is finalized, we want to release that so it's immediately available, because we don't want this to be one huge suite of tools. You have to use it all to get your end result. We want it to be modular, and we want it to be used as needed. So maybe you only need one tool for what you're going for and you don't need anything else. And we want to allow that flexibility so that you just take what you need. So that's 2020/beginning of 2023 in a nutshell, a lot of our efforts that we've been working on. So if you want to connect more with us, if you want to find out more of what we're about, there's a few different ways. One that leans kind of more on our education side is our art station. We try and make posts for a bunch of our tools to demo in an artistic sense how they work, how you can get artistic results out of it, and we actually have a few tutorials on here as well, just more education and learning material. We've released a public roadmap in the past year that shows what we've released by category. So you can go and see like what we've done in world building lately with a little description, a little demo, and there's a button at the top. If you have an idea you'd like to submit, you can submit that directly to us and we can go and review them. Like I said earlier, Fast Remesh was a community contribution. And so we really like hearing from people who are excited about labs, excited about Houdini, and want to help us out. We have a Twitter page where we also post updates. Myself, Christos, and Mai post on our own Twitters, and then SideFX Labs will like repost relevant tweets. I'd also post about little industry tips or industry trends or tutorials we like or stuff from SideFX. It's just sort of like a communication hub for SideFX, or SideFX Labs. But if you want to be on the cutting edge of the latest and greatest labs, you can go to our GitHub page, and it's a public repository and you can read each entry and see what we're updating. We are on a separate development cycle from Houdini, so we don't release like with the 0.0s or 0.5s, we release weekly. We're making adjustments weekly. And to see exactly what we've done, you can go into our public GitHub and read everything. Like we have different tags, like a tool was updated, a new tool was released. It'll say bug fix if a bug was fixed, maybe if it's on your favorite tool and you want to go see that. That's where all of our latest updates are. So thank you so much for coming out and listening to me. I'm very excited about SideFX Labs, and I really appreciate everyone who came to hear me go on and on about it. So we have a few minutes for questions, I think, if anyone wants to ask me any questions. Yes, Deb. Oh, there's a mic coming around. Okay.
Thank you. First, amazing work, you guys, on SideFX Labs. As a teacher, it's super helpful, and I love using them and exposing them to my students. Quick question about the aliases. Is that kind of like presets?
Yes. So they do work as presets. It's a little different from like if you were to select a preset from a drop-down menu, because you can access the alias from like the traditional Houdini tab menu where you open it up and you type in the name of the alias and it will pop up. So it's just one step, removes a few steps of work. I remember once I needed to calculate tangents and bit tangents on a model. Mm-hmm. And I didn't know if there's any Houdini node that did that right away. I didn't know, so I just opened the tab menu and I typed in tangent. And a node popped up, and I was like, oh, cool. And I put that down, and it worked immediately. And what that node was, it was a alias for polyframe, which had all the tangent presets selected already. And so that was very helpful. And that's what made me a huge believer in aliases. I'm like, okay. Oh, yeah, let's make more of these.
Gotcha. Okay, thank you.
Mm-hmm.
Yeah, so I wanted to ask how separate is the labs team from the SideFX team? So, for example, what's blocking you guys from just making a toggle on the standard transform nodes to make it transform from center?
Right. So we're part of Houdini, and we work very closely with all different areas of SideFX, like R&D. We work very closely with, but we don't do any development on the back end of Houdini. We are taking what's already in what we call native Houdini, and we're wrapping it up into HDAs or tools, or we're creating these aliases. These aliases are actually a modification of like shelf tools. We use the same Python files in the tool shelf directory or whatever, and we modify these files to make these aliases. So we're working with what we have, but we don't do anything on the back end. But yeah, we do work very closely with R&D, and we're always in communication. And even some of our tools, we say they graduate to Houdini native, like they start out in labs, but R&D is like, oh, we want to graduate this to Houdini native, and then they become responsible for supporting that tool.
Will those tools then also become closed or like rewritten?
I'm not sure. I'm not sure if those tools are closed. That's a very good question. Do you know? I'm picking on Christos here.
They might get rewritten in C++.
Okay, yeah.
And they might get closed, but I'm not sure either.
Yeah, we're not sure. Any other questions?
Yeah.
I got mine answered with the
So what does the shelf look like now? You just customize it with your own, handful of tools that you use regularly?
The shelf, so I only use the shelf tool, like, are you talking about like the shelf at the top? It depends on what you, because the shelf tool is very versatile. So the way I personally use a shelf tool is you can actually drop down, a cluster, a network of nodes, and you can select those and drag and drop it to the shelf tool, and it'll remember that configuration for you. And that's also the idea behind how we make aliases. So I'll do that for specific things, like I use that for, like if I want to copy spheres to points, like I drag and drop that on the shelf. If you're asking about the SideFX Labs shelf tool specifically, like the shelf specifically, I don't think we've updated that shelf in a while. That might be something that we look at if that's what you're asking about.
Hi. Oh, that's loud. Could people outside of SideFX or potential interns contribute to Project Vitruvius, or is that kind of just for like other people?
Yeah, so these big projects have introduced something new for me personally, which is project management and project planning, which this is my first foray into it. And as I did quite a bit of research on project management before even jumping into Dryad, because I inherited Dryad from previous members of Labs. And as I'm sitting there managing out the project, I'm like, I'm going to need help on this. So we do want our interns to sort of help with these big projects. We would like to open it up to alpha testers. So as we're releasing tools, we'd like to have those tested and vetted by people before they're like officially released. If we can find a way for community involvement, that would be awesome. But I know it requires like communication and making sure like quality control is there. But we are certainly very open to community contributions. So if you have an intern that's like really interested in some of this stuff and they want to chat with us, we'd be more than happy to like see if we can work something out. I don't see why not. One up here.
Yeah, so if the aliases are shelf tools, and you guys don't work on sort of the backend, how do you implement the new VEX functions? And is there a way we can sort of make our own VEX functions?
Yeah, absolutely. So VEX functions are, let me see if I can maybe go back. Because I wrote the directory down specifically. Where is it? It's soon. Or did I pass it? No, it's coming. There it is. So the VEX function is under the SideFX Labs directory. Then you go to the VEX folder, and then it's in the include folder. And it's these files right here, SideFX Labs _data.h. And you can write your own VEX functions and store them in this way and call them as you need them. Yes. Absolutely. So these are just our custom functions. But anyone can write their own custom functions and use them however they want.
Any more?
More? All right, thank y'all so much for coming. Thank you.